How's it going? That last talk was really freaking great. And I wondered to myself, I'm like, I maintain this web compiler, and how many tiny character tricks could we take from this? But anyways, maybe that's for a minifier. So yes, thank you. So the title of this talk is Webpack 4, the state of the art. And so for those who don't know me, I am Sean Larkin, and so I'm a project manager or program manager at Microsoft, working at Microsoft Edge and Edge Dev Tools. But you may know me as being one of the maintainers of the Webpack core team, and also spent time working on the Angular CLI, and just a general evangelist for open source sustainability. And then now, kind of with my involvement through Microsoft and Webpack, helping represent you all at the Node.js Foundation for modules, and also WebAssembly in their community group. So a little bit about myself is I'm a technical support rep gone rogue. I got tired of not being able to solve people's problems, and so I started learning AppleScript. Who wrote AppleScript? That was my first programming language. And then Ruby, and then Objective-C, and then finally I found JavaScript. I also like woodworking and Internet of Things. But like I said, sustainable open source practices is one of probably my latest passions that I've been following. Now, you can find me anywhere, anywhere, in most places, with @thelarkin. And so if you wanted to tweet this out right now, I'll give you a second, take your time. There's no rush, but you can find me on any of those places. So back to the talk. Okay, so Webpack 4, the state of the art. And state of the art. So I just wanted to pull up a little definition, and hey, is that how you'd say it? A stand off the list? Is that the Icelandic version of that? I'm not sure, but we're talking about the recent stage of development, or I don't want to call what we do avant-garde, but at least, the latest release and what we're talking about today. And so, like it was mentioned, we did just release Webpack 120 hours ago. And it's here. It's in latest. Webpack 4 is out, and you can get it today. But I want to talk about what Webpack 4 represents. And so, for the first time, we decided to take and give our major releases a code name. And so this is called Webpack Legato. So you might be like, what? Legato? I'm a music major, so in college. So anybody else did music? Okay, so you understand what legato means. It's to express notes in a flowing manner without gaps in between them. But we got this term from our major sponsor, Trivago. So we wanted to give the opportunity for one of our largest sponsors to name this major release. And so this was kind of their explanation. At Trivago, we usually give our projects a name and a musical theme. So for example, their old JavaScript framework was called Harmony. Our new framework is called Melody. And on the PHP side, they're using Symfony. And the top layer is called Orchestra. And so legato, meaning to play without gaps, expressive through each note, to them really embodied what it meant to have Webpack 4 in their build system, and how it ties everything together. Before I go on and explain more, I want you to just look at one of these slides, or to each of them, and if you see your company there, or yourself, I just want you to stand up right now. So if any of this is you, stand up. I know there are many, please. So I want you to look around, and I want you all to give them a round of applause, because because without these people, we would not be here today, and Webpack 4 may not exist. So I just wanted to take a second and recognize those people. So we wanted to kind of create this higher level story about what Webpack 4 meant for our users, meant for us. And so, the first thing was smaller builds and faster builds. And the second was modernization. And then finally, probably one of the most important, well, I mean, all of these are really important and not mutually exclusive, which is developer experience. And if I talk about smaller and faster builds and we try and break it down, you can kind of categorize it here. So like, to have a smaller build, you're going to need to do more analysis on the code. And you're going to have to process more of the module graph. And then for faster builds, though, you're going to have to do less work and reuse existing work that's already been done. So these are kind of conflicting. But for faster builds, we completely re-architected the way that we define what a chunk is. And a chunk is just the in-memory version of the bundle UC created. But we also added additional features like Uglify.js. We're going to be using it in parallel and caching it out of the box. And we also modernized a lot of the pieces that we had in just old ES5 object syntax, and we moved to using maps and sets. But specifically, I think one of the most important is the migration of our plugin system. We wrote it completely from the ground up. And now we have what are called hooks, which create monomorphic code. And we lazy compile them. And I want to actually take a moment to explain, well, what does this even mean? Who here is familiar with monomorphism or polymorphism? Okay, so this may look familiar. So this is an example of one of the methods that is available in our plugin system prior to rewriting it. And so if you see here, this method is what certain classes in Webpack will call, and plugins are listening to this event. And what's passed in is a arbitrary event string. It's like an event emitter, if you've ever used it before. But the problem here is that this is polymorphic. It can be any amount of arguments, and there's no way for the JavaScript engines to optimize this. So, our initial answer was like, well, why don't we get clever and just make separate methods with single arguments for each of them? But that was not going to work. One, because we could have a plugin system that's ginormous. You have infinite amount of different event names and argument types that can be passed in. And so it's unmaintainable and not really a great contributor experience. And so it's like, how could we solve this where we're creating monomorphic functions, but they're unique, and we don't have a billion of them that we have to maintain. So we use the technique to lazily compile based on what is listening to these events. And I know I'm going a little deep here, but it might make more sense in a moment. But you can see at the bottom, we're literally just composing a bunch of strings that are JavaScript that compile to these hooks, and then we evaluate it. And so a really great resource if you're interested in this, and I'll try not to butcher the name, but Vyacheslav Egorov wrote a great explainer article that you can go to and take a look at it to understand how this accomplishes monomorphic code. And if you're on Twitter a lot like myself, you may have seen this article that was like, hey, you may not need Rust and WebAssembly to speed up your JavaScript. Well, it turns out, I was like, oh, that looks pretty familiar. The code that he showcased. And look, he's doing the same thing. So the point is that we can create this monomorphic code, but we're doing it kind of evaluatively or lazy compiling it. But please do not do this in your normal projects. This is, there are some parts of Webpack that execute 19 million times on large code bases. And so everything is in the hot path for us. And so just as Benedict Moyer says, or V8 Senpai, please don't do this. Please don't. But so, what did this represent to us? And so on most Webpack builds, we saw it get 98% faster. So 98% of the build time was reduced just by people upgrading to Webpack 4. 98. Yeah. And you'd be like, Sean, you're lying, stop. You embellish all the time. And I'm like, well, it turns out that we have people who are reporting 6 hours of their build times on Webpack 3. Actually, it was 9 hours, but he stopped it at 6 on this run. And so we were like, we have an idea. And after showcasing this in the Webpack 4 alpha, we found out 17 minutes. 17 minutes from 9 hours. So, there's the URL. You can go to it. I'm not lying. And just to make sure, so that people would be like, Sean, you're still lying, once we got into our release candidacy, I decided to, play a little game to see, hey, one, could we get people to upgrade to the beta so that we could catch early bugs, warning signs, things like that. But two, is this speed boost really, is this for real? So, I shot this out, and we were seeing 75%. On some cases, we were seeing 90%, 80%. And so, it's the real deal. And so, that build speed, to sum it up, we were able to accomplish that first piece in what our goals were. But then we still had smaller builds. Now we had to do something basically completely opposite to what trying to get a faster build will do for you. So the first thing that we tried to implement, and we were able to do so, is JSON tree shaking. So if you ever use JSON with Webpack, you'll notice that in version 3, it would bundle all of the pieces that you would import into it. But we found out that really, JSON is just a stricter set of what JavaScript is. And so we could treat it like an ECMAScript module, and only the pieces that are now used will actually will stay in your code. And so in this case, you can just see we're just pulling in and importing one property, and that's all that actually compiles when we minify the code. We also have a feature, well, I'll explain the problem first. So according to the ECMAScript module specification, or the Harmony module spec, when you have multiple exports inside of a file, every single one of them has to be evaluated and executed to ensure that they are not creating side effects against each other. So what does that mean? Well, if Lodash is exporting from a file, essentially 1,000 exports, each one of them has to be included into your bundle. So what we did, and you can see that here in this tiny example. So what we did is we created this trick. We had to tell the compiler some way hey, there are no side effects here. You can go ahead and ignore those properties. And so that's what we did. We created the side effects property, which now we're asking library authors to include in their package.jsons. Because what Webpack will do in production mode is it will look for the presence of this property, and it will simply prune it out. And in fact, it actually makes builds faster. When we were in the beta stages, we found that our production builds were faster than the development mode builds because of this feature. Because what you're doing is you're ignoring tracing those parts of the graph because you know they aren't actually used. So in this case, we saw something like in Webpack 3, 200 KB of minimized code actually turned to 1 KB. So really, all you need to do if it's so easy. All you have to do is just tree shake, mangle your exports, scope hoist, minimize, and then package authors have to set side effects. No! That's ridiculous. You shouldn't have to do any of that. And that kind of gets into what developer experience is about. All you should have to do is freaking run Webpack. And so out of the box, now in Webpack 4, we default to a production mode. So all of those things you saw in that bullet point, they just happen. And so developer experience to us meant we need to lower the barrier to entry to people who are trying these tools for the first time. Not everybody understands the rigorous and obnoxious history of JavaScript modules and where they started and where they are now. And we also need to have better defaults. And thanks to libraries like Parcel, we can now coin something like zeroconfig.js. And to us, zeroconfig doesn't mean, like letting you do whatever you want and shoving it into one package and then hoping not the feature that you don't use breaks and causes a major breaking change. It means being able to actually extend a base scenario to your users so that it can BYO or bring your own zeroconfig.js. And so this is really the line that we wanted to cross. So, by default, you don't even need a Webpack config to use Webpack 4. Every property has been defaulted. And what the future... yeah. Now, what I'm trying to say, though, is that not everybody will end up, just ripping out their Webpack config. Because the power of Webpack is deeply rooted in how extensible we are. And so, instead, why don't we extend this idea? So we also created this feature called mode. And so mode is a property on the config or a flag that you can pass in the CLI, and we default to production, like I said. And what it represents is that for development, you're going to want to have tooling for the browser. You're going to want to have really fast incremental compilation. And you're going to have better error messages that don't take up an entire console. And then for production, we're optimizing for size. We're optimizing for the right kind of source code. And we're optimizing for file paths that are understandable but don't leak information to the people using your website. But it also means getting rid of things that used to really cause us problems, like the Commons chunk plugin. In Webpack 4, it's gone. We've replaced it with an API that does much of this out of the box by default. But on top of that, we have properties that give you more control than Commons chunk did. And then finally, build speed was something that we took so seriously that we wanted to be able to profile and analyze really deeply any long-running build. And so we worked with Sam Ciccone from Google, who helped us implement a special profiler that allows you to see every plugin and how long it takes right inside of the DevTools timeline viewer online. So now you can literally see, and I mean, this information may be more valuable to us, but it allows us to just say, hey, pop in a plugin and send us the events.json file. And it's really useful for those who are creating plugins themselves and trying to analyze interactions. And that kind of leaves us to, the modernization and the re-architecture. So, one of the most important things that kind of held us back in Webpack 3 is that we treat everything as a JavaScript module. But we also were championed with being able to implement WebAssembly as a first-class citizen. And so this gave us the opportunity to remove all of these everything is JS hacks. Or it allowed us to actually implement WASM as a module type, which allowed us to also implement JSON as a module type. And it gave us JSON tree shaking. And then what we're working on right now is HTML and CSS module types. So we had to take and remove all from, our module factories is what we call them, all of the code generation system that was specific to JavaScript, and we've, isolated it. And so now, with WebAssembly as a first-class module type, you have code like this. This is a newer library called Walt. Who has heard of Walt? It's a subset of, I guess you could say TypeScript. And it allows you to write a very JavaScript-like syntax, as you see up at the top. And then all you have to do is import it, just like it's a JavaScript module, into your code. And you have used WebAssembly without doing anything else at your fingertips. This is probably one of the most exciting things to me, is that you want to use A-frame or you want to use these things. Now what these these library authors can do is instantly compile a WebAssembly module. And if it's available in the package, Webpack will consume that instead of the JavaScript. And so you get the 10x speed up instantly at your fingertips. And so the other pieces were dropping Node 4. So Node 4 is no longer supported for Webpack, and Node 6 is our minimum version. But this allowed us to convert the rest of the code base to using ES6 features. It allowed our code to be more readable, easier to change, using syntax that people understand and contributors want to actually leverage. And now, by using this new code, V8 actually has a great test bench for optimizing paths that aren't as hot yet, that should be. And I mean, as it was said, we're just scratching the surface on all the different changes that we've made. And so, smaller builds and faster builds, modernization, developer experience, that is where everything was rooted in. And so you might be like, all right, Sean, this is great. How do I migrate? So right now we have the PR pending for our migration guide. And I'll talk about it a little bit more. And then what about for frameworks and plugins? Well, we've been working, ever since we released our alpha, behind the scenes with Create React App, Preact CLI, the Angular CLI, Vue CLI teams, to make sure that, and we put extra focus on them to ensure that they had a steady path and there weren't blockers for them to test early. But for right now, until we get that migration guide merged, I'd say jump on our Medium publication or submit an issue and ask how you can help. And like I said, the Angular CLI is actually going to be now supporting it in their next major release, which I believe is next week. So look to have that automatically out of the box for you. And then, shameless plug to me, you can always jump on my Twitch live stream, which I do 2 times a week. And you can ask me questions anytime. We work with people just to help them migrate. We also get people to contribute to the code base and, submit their first PR ever. And even more so, we wanted to make sure that this worked at scale. And so Ken Chaw, who's surprised appearing in these slides, he is one of the lead engineers for the Outlook web app team. Well, as of, I think, a few days ago, or was it yesterday, the Outlook web app is now using Webpack 4. Not only did the size of their builds instantly shrink without making any changes, but their build times and their inner dev loop jumped from 100 seconds to 20 seconds. And on a 150-person team, we're talking millions of dollars of dev time saved. And so we're hoping to accomplish that not just for Microsoft and the Outlook team, but by vetting it and dogfooding it in that way, we can ensure that it's a great experience for you. So what's next? What's beyond Webpack 4? So the things that we're going to focus on are finishing the CSS as a module type, HTML as a module type, URL and file as a module type. But as you can see, what this means is you don't have to use Extract Text plugin anymore. You might not even need, yeah, I know. You might not even need to have a CSS URL file loader. We might just have this supported out of the box as a module. You'll be able to say hello to CSS code splitting, something that doesn't exist today and actually, causes kind of a pain point for, browser and load times. But you could also have HTML as an entry point. And then the other big feature that I'm really excited about, which is called Webpacking WASM Part 2. So, when we introduced WebAssembly as a first-class citizen, we kind of can, the module type is called WebAssembly/experimental. And so the first thing is to stabilize it. But then we're going to go ahead and add a bunch of the features that we already have on JavaScript and apply it to WebAssembly. And so this means tree shaking. You can do that. Dead code elimination. Scope hoisting WASM modules. And so this is super exciting because now WebAssembly goes from being something that you can use once or twice to using it just like any other JavaScript module and not taking a perf hit or a size hit or a runtime hit. And then maybe something that's really special for me is presets. So like I said, bring your own zero config JS. These are just examples that I played around with in a prototype. But what if it would be just this easy to say, at Webpack can use Babel if exists? You can install that package, and it just reads your Babel RC and throws in Babel loader. What if, as a package author, you have these composable parts that you can share and leverage? This looks very similar to Babel if you understand their package structure. At least I took the inspiration in this prototype to kind of leverage it. But can use TypeScript really could just be, can it resolve TypeScript and can it load it using a loader? But the point is that this is how you can extend zero config. So with a couple packages that you would add, you still don't need a Webpack config. Yep. Thank you. And so what's beyond 4.x? So those are the kind of like the things that we can do right now without causing a breaking change. But what's beyond that? So one of the most important things that is lacking for Webpack is that we don't have a fully persistent cache. And so that's the first one that we're going to be working on. And so we actually kind of worked really closely with the author of Hard Source Webpack plugin, who has probably the most experience with our code base and disk caching. And so he wrote up a specification, and you can take a look at it on GitHub. I think it's under the Webpack 5 tag. But also things like multi-threading our builds. Actually, when I saw the presentation yesterday about having workers be native, that was really exciting, especially to us who wants to be able to have something right out of the box from Node. But also have all of our experimental module types become stable. And then what if we could bring your own module type? What if you could write a module type that makes you not even need a TypeScript loader? What if you could take those types and treat it as metadata and allow it to do static, program flow analysis and make your code even smaller? I see a future where you want to use TypeScript with Webpack because it creates smaller bundles. And so I really have see a promise for bring your own module type. To be honest, these things are just a reflection of what you ask for. And so, did you know that every single one of you, if you have a GitHub account, can go to webpack.js.org/vote. And every day, even not as a contributor or a sponsor, you get one piece of influence every day that you can vote on a specific feature. So, literally, we put the power in you all because that's who we represent. You saw our sponsors and backers. We're a grassroots project that represents exactly what it means to have web performance and developer experience without making a sacrifice to each. And finally, we shipped Webpack 4. What did we take away from it? One of the things that we announced when we released the release candidate was that, we said, here's 30 days, plugin and loader authors, you get 30 days to upgrade. We're not going to break any changes between our RC and final. And that was great for our team, who owns a lot of the core plugins and loaders, but it was a lot harder for people who, third-party plugins. And so I think what we're going to do is focus more on providing a migration guide for loaders and plugins, and even just general updating versus having a time window. And overall, like I just said, I rambled about it a little early, but what we do is exactly what you asked us to. And so we see this year of JavaScript as being, no more talk of this fatigue. But instead, it's having this mindset of embracing the changes of our technology that are so beautiful in JavaScript. Some joke that we see a new framework every 2 weeks, but that's the most beautiful part of our language. In what other language do you get to use syntax that doesn't exist yet? Without a VM, for you Java people. Because that doesn't count. There is no other language. It's a JavaScript renaissance. And so we embrace this. We call it even a growth mindset at Microsoft. And so we ask you to do the same. and help Webpack just not be yet another build tool. So thank you guys very much. Oh yeah, and try Webpack today.